Hello, hello, and welcome to this video on read through of PostgreSQL documentation. So first of all, I would like to apologize because the last video was on 7th and now today is 14th. Well, it is very early morning for me, 2 a.m. So roughly a gap of 6 days, which is very bad because my intention is to finish PostgreSQL as fast as I can. The reason being is if you follow my channel, then you know that the main reason of uh, going through PostgreSQL is that I have two other playlists or other three which will involve web development. Those are JavaScript, Python, and Rust. We will learn web development in all three. So we need a database, and PostgreSQL will be our choice of database. In fact, we will not do PostgreSQL, rather we will do Yugabyte. But Yugabyte basically is a distributed PostgreSQL. It, in fact, keeps the source code of PostgreSQL in the repository. It builds on top of PostgreSQL. A lot of features are there. Storage engine is different, but that's the another thing. So when we learn PostgreSQL, we learn the querying of Yugabyte and to a large extent CockroachDB as well. So my sincere apologies for not recording the video because last few days because I was getting caught up into something or the other thing. There was change in the routine as well. So there were problems in last 5 6 days. I'll try my best to record one video every day on PostgreSQL. So with the apology, I hope that you accept it. We had read till regular expression escapes. So we will start with regular expression metasyntax, and we have roughly 5 pages to go through. And we'll try to finish this pattern matching in this video. We'll wrap it up. So without further ado, let's get started. Okay, I think I can put this in full screen so that the fonts are even bigger. Let me zoom a bit as well. No, this is best. Okay. So the first thing is that we have covered the most important part of regular expression already. What we are going to study is not as important as what we have studied. So if you have not watched my previous video, I would suggest that you go and watch them before watching this video. And if you have watched them, then you can take this lightly. It is not something really critical for understanding PostgreSQL or most of the operations. We will not ever probably touch metasyntax of PostgreSQL when we are querying. So let's get started with the read through. In addition to the main syntax described above, there are some special forms and miscellaneous syntactic facilities available. An RE can begin with one of two special directed prefixes. If an RE begins with triple stars or asterisk, the rest of the RE is taken as an ARE. This normally has no effect in PostgreSQL since REs are assumed to be AREs, but it does have an effect if ERE or BRE mode had been specified by the flags parameter to a regex function. If an RE begins with, there is colon as well, okay, I forgot the colon. If an RE begins with triple star is equal to, the rest of RE is taken to be a literal string with all characters considered ordinary characters. An ARE can begin with embedded options, a sequence, for example, question mark XYZ in parentheses, where XYZ is one or more alphabetic characters. Specifies options affecting the rest of the RE. These options override any previously determined options. In particular, they can override the case sensitivity behavior implied by a regex operator or the flags parameter to a regex function. The available option letters are shown in the table 9.24, that is this table. Note that these same option letters are used in the flags parameter of regex functions. So we have embedded option letters, which are B is that B tells us rest of RE is a BRE. If you don't know BRE and ARE and all, you need to watch previous videos. C is for case sensitive matching, overrides operator type. E is rest of RE is an ERE. I is case insensitive matching. M is historical synonym for M. N is new line sensitive matching. P is partial new line sensitive matching. Q is rest of RE is a literal quoted string, all ordinary characters. S is non-new line sensitive matching. T is tight syntax. W is inverse partial new line sensitive matching or weird matching. X is expanded syntax. So lots of it is below. Embedded options take effect at the closing parenthesis terminating the sequence. They can appear only at the start of an ARE after the =* colon directory, if any. In addition to the usual tight RE syntax in which all characters are significant, there is an expanded syntax available by specifying the embedded X option. In the expanded syntax, whitespace characters in the RE are ignored, as are all the characters between a hash and the following new line or the end of the RE. This permits paragraphing or commenting a complex RE. There are 3 exceptions to that basic rule. A whitespace character or hash preceded by backslash is retained. Whitespace or hash within a bracket expression is retained. Whitespace and comments cannot appear within multi-character symbols such as $, For this purpose, whitespace characters are blank, tab, new line, and any character that belongs to the space character class. Finally, in an ARE outside bracket expressions, a sequence $hash triple T. Where triple T is any text not containing a right parenthesis or closing parenthesis is a comment completely ignored. Again, this is not allowed between the characters of multi-character symbols like opening parenthesis $colon. Such comments are more a historical artifact than a useful facility, and their use is deprecated. Use the expanded syntax instead. None of these metasyntax extension is available if an initial =* is equal to director has specified that the user's input to be treated as a literal string rather than as an RE. So I generally read the star, they are asterisk. So I'll repeat here. I have roughly 26 years of experience developing systems, but I have rarely, in fact, I don't remember when I last saw the metasyntax of PostgreSQL. Now, next section is regular expression matching rules. In the event that an RE could match more than one substring of a given string, the RE matches the one starting earliest in the string. If the RE could match more than one substring starting at that point, either the longest possible match or the shortest possible match will be taken, depending on whether the RE is greedy or non-greedy. Whether an RE is greedy or not is determined by the following rules. Most atoms and all constraints have no greediness attribute because they cannot match variable amounts of text anywhere. Adding parentheses around an RE does not change its greediness. A quantified atom with the fixed repetition quantifier, that is M, has the same greediness as the atom itself. A quantified atom with other normal quantifiers, including Mn with m equal to n, is greedy, prefers longest match. A quantified atom with a non-greedy qualifier, including m, n with m equal to n, is a non-greedy, prefers shortest match. A branch that is an RE has no top-level pipe operator, has the same greediness as the first quantified atom in it that has greediness attribute. An RE consisting of 2 or more branches connected by the pipe operator is always greedy. The above rules associate greediness attributes not only with individual quantified atoms, but with branches, the entire REs that contain quantified atoms. What that means is that the matching is done in such a way that the branch or the whole RE matches the longest or shortest possible substring as a whole. Once the length of the entire match is determined, the part of it that matches any particular sub-expression is determined on the basis of the greediness attribute of the sub-expression, with sub-expression starting earlier in the array taking priority over ones starting later. An example of what this means is we have x, y, z, 1, 2, 3, 4, z, and then we have y star. Okay, star means 0 or more. So it will match, star will match after y. Now in the parenthesis we have 0 to 9 and 1 to 3. So this will go for longest match. So 1 to 3 will be longest match here. So 1 to 3 because 1 to 3 such characters are to be matched. Now again we have x, y, z, 1, 2, 3, 4. Now here question mark is there. So it becomes non-greedy match. It will match the shortest, that is one alphabet or alphanumeric character it will match, that is 1. In the first case, RE as a whole is greedy because Y star is greedy. It can match beginning, so it's the whole explanation of the same thing. Star is greedy and question mark is non-greedy, and that is why it matches the whole thing. So I'll skip this part. In short, when an RE contains both greedy and non-greedy sub-expressions, the total match length is either as long as possible or as short as possible, according to the attribute assigned to the whole RE. The attributes assigned to the sub-expressions only affect how much of that match they are allowed to eat relative to each other. The quantifiers 1, 1 and 1, 1 question mark can be used to force greediness or non-greediness respectively on a sub-expression or the whole RE. This is useful when you need the whole RE to have a greediness attribute different from what is reduced from its elements. As an example, suppose that we are trying to separate a string containing some digits into the digits and parts before and after them. We might try to do something like this. So we have ABC, which are non-digit, 0, 1, 2, 3, 4, which are digits, and X, Y, Z. So we quantify dot star and then D plus and then dot star. So dot star will match 0, 1, 2, 3, 4, 0, 1, 2, 3, because it's a greedy match, and for D plus it will manage only 4, and X, Y, Z will be the last D dot star. That didn't work. Dot star is greedy, so it eats as much as it can, leaving backslash D plus to match at the last possible place. You might try to fix that by making it non-greedy. If you make it non-greedy, it will match ABC, but then D plus will match only 0. Okay, D plus means 1 or more, and rest will be matched by nothing. Okay, or empty string. You see why this happened. That didn't work either, because now the RE as a whole is non-greedy, and so it sends the overall match as soon as possible. We can get what we want by forcing the RE as a whole to be greedy. So we have the regex match here, question mark colon dot star question mark and then backslash D plus dot star, and then we make the whole RE greedy by specifying this 1, 1 here. Now the match will happen. Controlling the RE's overall greediness separately from its components, greediness allows great flexibility in handling variable length patterns. When deciding what is a longer or shorter match, match lengths are measured in characters, not collaborating elements. An empty string is considered longer than no match at all. For example, BB star matches the 3 middle characters of A, B, 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 C. Week or V, night or nights matches all 10 characters of weeknights. When dot star is matched against ABC, the parenthesized sub-expression matches all 3 characters. And when A star is matched against BC, both the whole RE and the parenthesized sub-expression match an empty string. If case-independent matching is specified, the effect is much as if all case distinctions had vanished from the alphabet. When an alphabetic that exists in multiple cases appears as an ordinary character outside a bracket expression, it is effectively transformed into a bracket expression containing both cases. For example, small x becomes small x and capital X. When it appears inside a bracket expression, all case counterparts of it are added to the bracket expression. For example, x inside brackets becomes both, and negation of x becomes negation of xx. This is for case insensitive matching. If new line sensitive matching is specified, dot and bracket expressions using caret will never match the new line character, so that matches will not cross lines unless the RE explicitly includes a new line, and caret and dollar will match the empty string after and before a new line respectively, in addition to matching at beginning and end of the string respectively. But the ARE escapes backslash capital A and backslash capital Z continue to match beginning or end of string only. Also, the character class shortens backslash capital E and backslash capital W will match a new line regardless of this mode. Before PostgreSQL 14, they did not match new lines when in new line sensitive mode. Write caret digit class and word class to get the old behavior. If partial new line sensitive matching is specified, this affects dot and bracket expressions as with new line sensitive matching but not caret and dollar. If inverse partial new line sensitive matching is specified, this affects caret and dollar as in new line sensitive matching but not dot and bracket expressions. This isn't very useful but is provided for symmetry. Now one thing rather I'll say at the end, okay, we just go through this. Then we have limits in compatibility. No particular limit is imposed on the length of REs in this implementation. However, programs intended to be highly portable should not employ REs longer than 256 bytes, as a POSIX compliant implementation can refuse to accept such REs. The only feature of AREs that is actually incompatible with POSIX EREs is that backslash does not lose its special significance inside bracket expressions. All other ARE features use syntax which is illegal or has undefined or unspecified effects in POSIX EREs. The triple explicit syntax of directors likewise is outside the POSIX syntax for both BREs and EREs. Many of the ARE extensions are borrowed from Perl, but some have been changed to clean them up, and a few Perl extensions are not present. Incompatibilities of note include \b and capital B, the lack of special treatment for a trailing new line, the addition of complemented bracket expressions to the things affected by new line sensitive matching, the restrictions on parentheses and back references in look ahead, look behind constraints, and the longest shortest match rather than first match matching semantics. Then we have basic regular expressions. BREs differ from EREs in several respects. In BREs, pipe, plus, and question mark are ordinary characters, and there is no equivalent for their functionality. So we don't care about BREs as such. You always need pipe, plus, and question mark. We just discard BREs. Then we have differences from SQL standard and XQuery. Since SQL 2008, the SQL standard includes regular expression operators and functions that performs pattern matching according to the XQuery regular expression standard. I would rather bypass XQuery stuff. Okay. So it does not implement these. Okay, but approximate equivalent functionality is given here, and we have covered all these functions in great detail. Okay, we have seen all these functions. So we don't care about XQuery as such. Okay, we will just discard it. BREs and XQuery we will discard. We don't need to read this. So what I was going to say, one thing about regex is, before wrapping up the discussion on pattern matching, that you should be very, very careful when you are trying to use regular expressions. Never ever write complex regular expressions. It becomes a pain in your backside to debug it. And if you write a complex regular expression by being very smart, then it will bite you, or somebody who is maintaining the code later on will bite. One more thing is that it is not possible to keep all this in mind. Okay, so what you should do is stick to basics and learn the basic stuff. That's how simple stuff works. Okay, how star, question mark, brackets, negation, what are the meanings of backslash small w, capital W, backslash b, backslash small d, backslash s, and capital and small both w and s, and what is question mark, colon, question mark is equal to, and all that. What does plus do, what does star do? So if you understand look ahead, look behind, positive ones and negative ones both, then you are more or less settled, and the quantifiers for matching certain number of frequencies. If you know this much, uh, you will be able to write regular expression for roughly 99% of cases, and that is good enough. For remaining 1%, you should come back and refer to the documentation. And those will be few and far between. And one thing you should do is whenever you need to use regular expression, try to not use it. Okay, for example, if you want to validate email or say IP address, look for a library in your programming language and do it in the application rather than doing it in database. It is never a good idea to use regular expressions for complex stuff. Emails can be quite complicated, dates can be quite complicated, IP addresses can be complicated. So don't try to write regexes for that. If you watch my Python video on regular expressions, then you will see how we struggled to actually write a regex for something as simple as date. Okay, date means in the entire date, including year and month. So the general takeaway from regex is that although they provide a shortcut to do complex stuff easily, it is best to avoid regular expressions because they are kind of write only stuff. You write it once, then reading it is like pain in ass. Sorry for the word. So with this, I will end this video here, and tomorrow we will continue with data type formatting functions. Now this is going to be very useful for us. You always need to format data to certain output which you need, and this will come very handy when we need this. So with this, I will take my leave, and we will meet again tomorrow. Not at the same time, probably record the video a lot earlier. And thank you for watching the video. Your support means a lot to me. If you subscribe, then it makes me happier. And in any case, if you are just watching the video, that's pretty great. Okay. I would like to have feedback. So if you have something to say, please give me some feedback in comment box. What to improve and what not to improve. And I'll appreciate if you can watch the whole playlist and then give the feedback rather than giving the feedback as in an isolated manner on a particular read through. Because this was a read through, and you would say that okay, this is pretty boring theory. You are just reading the documentation. There have been a lot of practical examples, and I do give practical examples. So it is not only theory. Theory is being read for the comprehensiveness or exhaustiveness of the coverage. I have kind of an OCD to completely cover the material I touch. So I'll take my leave here, and you keep learning, and have a great day. Enjoy.